Welcome to this session about CI/CD in serverless and multi-environments. This is a topic that we are very passionate about because we have seen that good CI/CD makes a big difference, makes all the difference when it comes to dev velocity in an organization. My name is Martin Omander, and I'm a developer advocate in Google Cloud.
And I'm Adam Ross. I'm an engineer in developer relations in Google Cloud. How many of you have ever deployed to production from a documented checklist? Raise your hands. Oh, that's still a large number of people. OK. How many of you built a CI/CD pipeline to automatically run tests or deployments? Also, a lot of people.
That's good. A lot of people, yeah.
OK.
Excellent.
Well, today we're going to explore one particular organization's journey into building their own pipeline for automating these serverless operations, Into the Woods Camping Supply. And before we get too far, you should know that this is a made-up company. They're imaginary, but they've got some real-world problems that we've seen actual organizations face. And as we go through their decision-making process and their solutions, you might see some things that you can bring back to your own organization as solutions to your problems.
It's a shame they're imaginary, that they have such a stylish catalog.
Yeah, well, yeah. I don't know, that's the wrong shade of red. But one of their problems is they've had slower and slower release velocity because they don't have a good automation pipeline in place. So they don't really know when things go wrong, and when they do, they need to go spelunking into the depths of their code changes to find out how to fix it. So their existing architecture has one monolithic application and a number of microservices, each of them built as a serverless service. And they need to figure out, how do we approach these individual services and modernize how they're operated? We're going to go straight to a demo on what they end up doing by walking through a change. So the new engineering manager has the Friendly Failures initiative, which requires that all the error messages be friendlier. And we change. And let's go ahead and create a quick branch. Stage that code, commit. I hope let's watch conference Wi-Fi in action. That was really fast. OK. And so now we're going to open a merge request in GitLab. GitLab is the version control platform of choice for Into the Woods. GitHub and Bitbucket are all great products. This just happens to be what Into the Woods uses. And here we're going to open a merge request, which is roughly the same concept as a pull request. So now that I've opened this merge request, it immediately shows us a nice page that has the ability to open in a web IDE, check out the branch to explore it. But most particularly, we see this blue circle here next to a pipeline. A pipeline is the set of jobs that are run to ensure the quality and deployment process. And that's automatically kicked off as soon as I open that merge request. And we can dig into that and see what it's doing. So here we have a visualized display of different stages for this pipeline, running from testing all the way up through deployment and acceptance. And we're going to go deeper into the individual stages for this later. Drilling into just one of these, we see that there's a linting job for the payment process, and it's taking a little time to initialize this workspace, check out the code, authenticate G-Cloud, and oh, I have an error. Well, that's unfortunate. I guess I should fix that problem. And I also left a comma in the wrong place. So now that I've made a couple fixes here, I'll commit that. And we should see a new pipeline running through. I'm going to just take a quick look and make sure it's running. Yeah. While that cooks, we'll go ahead and move along. Can we go back to the slides?
So ops automation, one might think it's about computers, but I'm here to tell you it's about humans. And we all have our different views of ops automation. Junior James, he is a pretty junior developer at Into the Woods. He just wants to avoid frustration and bureaucracy, just bang out his code and deploy it and have it be tested and have it work. Process Pari, she's into processes and scripts. She has this idea of ops automation should be about reducing manual toil for the developers. Teamwork Tess, she focuses on teamwork, and she wants everybody to have confidence in the code and bring relief to the team. And finally, the fourth person in the engineering team here is Sang. He's the CTO. He wants to make it really clear to everybody what they're supposed to do as part of a release. And we'll see these four engineers here. They are going to discuss and build a CI/CD pipeline, and we'll see the final result at the end of the talk. So they will have to go through various things. There are 6 major decisions that they will need to make, from repo layout all the way through to security. They'll discuss, see pros and cons of various approaches, and arrive at a solution for each one. Repo layout, first one. It's foundational. Before you do this, you can't really do any of the other pieces. There are various ways you can do repo management. So, for example, Junior James, he's heard a lot about microservices and being super agile, and he's like, one repo per microservice, right? Keep everything light and really truly separated, these microservices. Pari notes that there are some integration tests. Where would they live? Tess notes that there are some code calling each other across microservices. Where would the API specs for that live? Also, Pari rightly notes that sometimes they need to run shared tools across the code base. That's really easier to have with a mono repo, single code base. And it's, of course, easier to share knowledge. So after some discussion, James is convinced, OK, let's try the mono repo approach. What would that look like? The layout might be something like this. Some files in the root, some docs folder, end-to-end test folder. We have the monolith. They are moving from a monolith to microservices. The monolith is still there, so microservices are still there. One directory for the monolith, one services directory with all the different microservices have their own subdirectories. They want to set up this for growth. Right now they have 5 microservices. They will have more in the future. Who reviews code when you check code in? Well, James has found a cool feature in GitLab, and it's in some other tools as well, where you can add a code owners file. That code owners file tells the system who should be the auto-assigned reviewers for any code that's checked in. And it also documents ownership. If you're just browsing the code, you know who to ask about a particular piece of code. Good. They've decided to go with monorepo. First decision made, 1 out of 6 done, and it's time to move on to number 2.
So next we have continuous testing, getting that test automation going on an ongoing basis so that every change is carefully measured and found to be acceptable to move forward. So junior developers might commonly think, oh, I can just run the tests locally, everything will work out just fine. But more senior engineers know that can lead to inconsistently running the tests and a lot of difficulty making sure that you're testing things the way they operate in production. Running end-to-end tests on cloud services can be a little tricky on your laptop. So they're going to take their existing work on building a testing pipeline and extend it to these new serverless services they've got. And maybe some of those automation engineers amongst you would find that fun, like Pari.
It does sound kind of fun, doesn't it? I would want to build this.
Yeah. So here we have the master branch from the repo. The master branch is commonly used as a release-ready branch to which all changes are merged. Now, shortly after the last release, a bug fix was begun. This branch has been in progress for a while, but in the interim, someone else came along, fixed a problem, and merged that to master. So when we look at this bug fix branch, ready to go, unit test passing, James is excited to merge it. Test knows, wait a second, even though that test is passing, it's showing green, there's a logical conflict between what is now in master and the change that James has been working on. Thank goodness there was an engineer on hand that has memorized all of the code changes that have gone on for the last number of months. So maybe the solution here is to have trustworthy tests. If your automated tests aren't reliable, pretty much all the time, they're not worth that much because you learn to disregard the results of running those tests. And so instead, we want to look into continuous integration. Continuous integration takes this continuous testing idea and focuses on how to make sure that if you accepted that change into your main line of code, would things still be passing? This is done by merging in the master branch here into the bug fix branch before running those tests, performing a code integration, not to be confused with an integration test, which is a bit of a different beast. And as we explore needing to build that pipeline, what kind of tools should we use? Well, one of the most important features that you might have for your CI/CD system would be a configuration as code approach, having the definition of those jobs and all the operations committed to your code repository so that the entire development team and any ops engineers and anyone else around that technical neighborhood can see those changes and weigh in on what they constitute and make sure that you're practicing a good and integrated DevOps sort of culture. Now, as we've mentioned, this team is using GitLab, and they're going to continue to use that for these new services. But in the future, maybe they'll outgrow GitLab, maybe there'll be some other considerations, and they'll consider other products, such as Circle CI, Travis, Jenkins, or Cloud Build, which is a product in GCP. A simple GitLab testing pipeline is made of YAML. I bet a lot of you here were thinking, oh, serverless track, we're safe from YAML, but not always. So here we have a stage that includes a test stage. It's the only one for now, but more will be added later. And every single job in a test stage runs in parallel. And our initial jobs are linting and unit testing. Linting is checking your code syntax, and unit tests are relatively quick to run tests. But we see that both of these are running Node. They're both running some implied service that they're testing against. So it's not necessarily a good fit for a monorepo. It's not testing a bunch of different services. So let's expand on that linting job. Now we have two linting jobs. One is testing a Node service named Relay, running the job inside the Relay subdirectory of the repo, and the other is linting a service built in Go, running inside a payment subdirectory. And as James is observing, this multiplication of the jobs is going to result in some slowdowns as more and more services are added to the repo. And so making the pipeline a bit more dynamic is going to help that process. Using almost any CI/CD system, you can introduce a little dynamic logic and take advantage of the fact that you're probably using version control. And you can run a slightly complex command such as this git diff here to list all the files that have changed and maybe only run the tests that apply to those files. And as it happens, GitLab has a trick for that. In the configuration, if you are running your testing pipeline for a merge request, you can also specify to only run that job if a file changes in a particular subdirectory. So here I see it is configured to only run if a file in the relay service has some kind of update. And you might be thinking this is getting a little complicated, but that's a trade-off from going with a monorepo. The tooling is often a little behind on that compared to having a service per repository. Lastly, with the monorepo and having all these services in one repository, there might be a tendency to have some of the operations leak into top-level directories or into this configuration file. Well, having those operations defined in the world's best-known task runner, bash scripts, you can get them isolated into those same subdirectories and make sure that those responsible for an individual service are also responsible for all the details of the operations. And perhaps in the future, this Into the Woods dev team will look into moving to something else that's a little bit more sophisticated than bash, maybe using makefiles or Bazel to run their jobs. And so by the time all of these steps are built in, we have a few different stages potentially coming together on just the testing pipeline. A pre-check here is showing the use of shell check, which is a utility that applies linting checks to bash scripts. Then test, running linting and unit tests against each of the services, and build, running any builds for those services that need a build process.
All right, so that was the end of step 2. Now we're 2 down, 4 to go. The next decision the team at Into the Woods need to make is how to manage automatic deployments. So there are a number of ways to do deployments, all the way from how CTO Sang did it before he was a CTO when he worked in a startup 20 years ago, through something that a junior developer might do with scripted development. The team really, though, they really want to focus on continuous deployment and delivery rather than these sort of semi-manual approaches, because that leads to more reproducible deployments and higher velocity. So James, he is happy junior developer. He checks in a bunch of code. It tests OK. He merges them, ready to go on the release train. Let's deploy it to production. Tess says, hold on a minute. How do we know that this won't break? Pari has a solution. We deploy it to staging. And we deploy it all the time to staging and keep running tests there. And that way we can see if it would break if we were to deploy it to production. Let's see what that would look like.
So adding deployment to this whole pipeline is really just adding an additional stage to the end of what we've already built. And that stage will include some new deployment jobs. These jobs bring with it more YAML for us to look at. A deploy job definitely needs to run a deploy process, and that will probably involve using gcloud, the command line SDK that allows you to run operations against GCP. So we have a shorthand authentication for gcloud to the cloud platform, and we'll go into more detail on that later in the security section of the talk. And then under the script, we're changing directory into the relay service, and we're running our functions deploy for that cloud function, which probably should be wrapped in a deploy script itself, but it's more clear this way that that is not a very complicated script necessarily. Now, if you were going to deploy instead a Cloud Run service, which you may have heard today across the keynote or other sessions, you know that you're dealing with serverless containers. They have a bit of a different deployment model. And so you are deploying a container image from Google Container Registry to your Cloud Run service. But it is just the same, a one-line command to make it happen. So we have added the new deployment jobs to the end of our pipeline. And so on every change, it will run through each of these stages, ultimately resulting in deployed code.
All right. 3 down, 3 to go. The next step is environments. How do we deal with that at Into the Woods? So just a quick reminder what environments are. We have the architecture. That's the design, right? What compute is in a microservice, what storage is in a microservice. Environments, those are instantiations of that architecture. And we have them for various uses, like demo and test and so on. All right, so the team sits down to discuss this. Pari says, let's minimize administration by having all these environments live in one GCP project. James is like, no, let's have them more isolated. Let's have one environment per GCP project. We'll have many, many, many projects. Well, we need to look into the pros and cons of each approach. So if each environment is a namespace, here we have QA and stage for the payments microservice. We have a payments compute part and a payments data part, payments for QA and for stage. So all in one project. It has certain advantages. Pari is right about that. There is easy access management. You go into IAM at once and set that up. It is also easy to just list all your resources in a project because it's all right there in one project. However, there are some global project settings that you might have seen around regions and data, app engine, data store, and so on, that we need to set once per project, and that could be hard to make all the different environments use those those global settings. Also, it's extra work to connect the compute and the data for these. As a matter of fact, it could get so bad that you cross-wire and there's crosstalk between environments. So the team decides not to have everything in one giant GCP project. Well, the alternative is every environment is a separate GCP project. So we have a staging project, and we have a QA project. So the disadvantage of this is there's more management, of course. We need to set up user access for every single project. Another one is we had to keep track of all these projects. What's good about this, though, is that we have really strong isolation with no crosstalk between environments. So the team decides to go with this approach. Now the question is, how do we avoid QA bottlenecks? In the old pre-serverless days, into the woods, there was one QA environment. And if you were working on a branch, you really wanted to test your stuff on that, and everybody was fighting to get their stuff on there. Well, new environments, everything is serverless. We can spin up as many environments as we want, right? Well, we do need to keep track of them. So maybe we should give each developer their own development environment and their own QA environment, rather than infinite environments. Let's see what that would look like.
So now that we have a plan around the number of environments, we have production, staging, and then a QA environment for each developer and a development environment for each developer so that they can experiment. And each of these environments is related to the code changes in some way. Production is going to be tagged off of the master branch when releases are cut, and master branch is going to automatically deploy to staging, and then individual feature branches will deploy to QA. One of the challenges with this arrangement of associating different pieces, different lines of code to different environments is how the CI/CD system understands how to route that. And for that, we have a bit of bash magic. Here, if the branch is master, this first part of the code says, oh, this must be for stage. And after the else statement, we're looking up a variable from the environment to associate the developer that pushed that last change, and that will map to that developer's environment. Now, you could hardwire that and say, oh, we're going to just use the test environment today. But by providing that little bit of separation, it provides space to then continue to expand this later to perhaps have multiple environments that might be routed to. And so using this arrangement, our earlier fix to the master branch is going to automatically deploy to the staging environment, and bug fix number 1, as it's going through its troubleshooting cycles, will be deployed to James's QA environment. Once that is approved to be merged into master, it too will be automatically deployed, updating the staging environment to the current picture of what would happen if a production release were tagged. And of course, once a release is tagged, production will be deployed.
All right, the team has decided on 4 out of 6 decision points. The next one is serverless testing. Now, this is a little different than regular testing. If you're testing something you run in your own data center or on-prem, serverless is a little bit of a different beast. So there are, of course, different types of testing. Junior developers think of unit testing. There's integration testing, system testing. Sang, the CTO, of course, he thinks more about end-to-end testing. So we have this whole spectrum of tests. One isn't better than the other. Some are really useful to developers. Some are more useful to business people. We need a mix of all these different types of testing. How do we do that? Well, so here again, we have bug fix 1, the branch James has created. He needs to merge this in. Let's see what testing happens at each place in this scenario. So whenever he commits code, that's the heart. James loves his code. It's a heart. There is unit test and linting in the CI workspace. So this still has nothing to do with serverless or nothing to do with Cloud Functions or Cloud Run or anything like that. It's auto-deployed, as we saw. It's auto-deployed to James-QA. This is James' own QA environment. And when it's auto-deployed there, there are automatic system tests running there. They run in the context of serverless, so this run on GCP, and you can use all the GCP services and databases and such. They're bigger than unit tests. Then when he merges into master, there are lint tests in the CI/CD system. And then it's auto-deployed to staging. There are system tests run, just like on James-QA. And there's also these more business-focused end-to-end tests are run in staging. And there, all branches are mixed up in staging too, so we test all of them. Broadly speaking, there are two types of testing environments here. Inside the CI/CD system, that's good for simple testing, like unit tests and linting. But when you actually test stuff like serverless databases and making calls and you're exercising more of GCP, then you actually need to run those tests on GCP. So there are various serverless options. You may know of serverless functions, Cloud Functions. You may know of App Engine. And earlier today, you heard about Cloud Functions. Cloud Run. Let's go through and see how you would test each one of these 3 serverless compute options. Testing a Cloud Function, you can do that locally. There are various ways of doing it. We really recommend, if you want to know more about testing Cloud Functions locally, you should go to our coworker Stuart's talk on Thursday afternoon, where he will dig into more details around this. For unit testing, you would create mock HTTP requests. And for system testing, well, in that case, you deploy to GCP, you get a URL, and then your test system hits that URL. Also worth noting here, Test notes that it's good to have sort of secondary, more complex logic in sort of secondary functions that aren't directly called. So that makes it easier to just sort of test those and troubleshoot those in a local environment before you deploy everything up to GCP. On App Engine, with the modern runtimes on App Engine, you do your local development and test using your regular tools or your regular frameworks, whatever you're using, Flask, Express, etc. Unit testing, there are mock libraries that mock out like task queues and databases and things like that. And for system testing, it's just like Cloud Functions. You deploy it to GCP, you get a URL, and your test system hits that URL. Also worth noting here is that App Engine has been around for a long time. So there's lots and lots of content, lots of articles and blog posts by Googlers and non-Googlers about how to test it. That was 2 of the serverless compute options. What about the third one that we heard about earlier today?
Well, since Cloud Run is new, let's talk a little about what it is to set the groundwork for how we would test in it. Cloud Run bridges the worlds of serverless and containers, providing a way to run a containerized service serverlessly. This means that you can build a service in a pretty conventional way, wrap it in a container, and deploy it. If you have no ops team, like Tessa's team seems to have, you can use managed Cloud Run. And otherwise, you can have Cloud Run on GKE, where you have a Kubernetes cluster underneath that your own ops team can manage. And with this arrangement, all the considerations of how you would test a container come into play. For local development and debugging, you might run your service locally using your standard tools, or you might choose to build that container locally and run it so that you are more closely simulating the production environment. For unit testing, you could also do the same. Run your unit tests the way you normally would when building code locally. Or you might also build a container that's loaded up with a number of development dependencies on top of the same production dependencies that you have on Cloud Run itself. And in that case, you can run the unit tests there and have available any of the system packages or other resources that are part of your service container. For system testing, much as we were suggesting with Cloud Functions and App Engine, go ahead and deploy your service to Cloud Run. It'll only be running when you're testing it, and otherwise it will scale to 0 and not cause you troubles. With all of the different jobs that we've been looking at with the CI/CD system, there is this workspace that is spun up in which we're running the linting checks, running unit tests, and running gcloud to trigger deployments. And one of the problems you might find are the performance concerns of what it takes to initialize that environment, then run all the tests. And waiting for tests is kind of a bummer. So one thing we can do is find ways to optimize just how big those workspaces are. Can we use a smaller container image as part of that CI/CD workspace to initialize the environment? Now, the main Cloud SDK Docker image that you might use in a CI/CD workspace is pretty fully loaded. It's based on Debian. It has a number of emulators and other things that you might not need initially in a service. So you might want to go with a more stripped-down approach, using an Alpine-based image. That's a lean distribution of Linux that's really popular in containers, and add to it just the pieces you need, in this case, for your Cloud Run work. And so the team here has built a slightly customized version of the Cloud SDK, pulling a static binary from Docker for the Docker client, and then adding that to the official Alpine version of the Cloud SDK Docker image, and installing the beta components which you need in order to interact with the Cloud Run service. This can lighten the size of this workspace container from around 700 megabytes to 120 megabytes, and that can save you a good minute of download time on each of those jobs. Another problem that can emerge from the particular way we've outlined the system here is the tendency to only trigger the tests when a developer takes an action. For continuously evolving software, that seems fine. You'll trigger the tests on an ongoing basis, and they'll continually be exercised. But for a mature service that has already been built and is running happily in the background without anyone the wiser, you won't notice if bit rot sets in and makes that service unstable if you were to try to deploy it or try to issue changes. And so rerunning the deployment and testing process on all your services is a valuable way to make sure that they are all staying in a healthy state, whether or not developers are actively working on them.
So with this, they've made decisions in 5 out of the 6 areas. They're almost there. The CI/CD pipeline is almost complete. There is one area that is very important, you should not forget about, of course, that is security. So the team sits down to discuss security. Pari notes that she needs, for her deployment scripts, they need some secrets to deploy to GCP. Tess notes that to hit the payments API that the payment provider has, she needs an API key. So here we see, right away at the beginning of the discussion, 2 types of secrets. We have operational secrets on one hand that deal with just managing all the builds and CI, CD, all that stuff. And then we have runtime secrets that are used by the runtime for when it does what it's supposed to do. At that point, James comes in and says, well, we have secure source control. This is not an open source project. Just deploy it all to source control. At this point, Pari has to come in and gently guide James and say that this is not something that one does. There could be accidental disclosure. I mean, we don't want developers to see the passwords and then accidentally enter it somewhere else. We also have contractors working from time to time at Into the Woods. Also, sometimes we share code with other companies. We could even have people potentially break into our source control system. These secrets need to be in a safer place than source control. How do we do this? Pari has a proposal. So let's manage the operational secrets separately from the runtime secrets. So everything starts with the repo, right? We have the source code there. No, James, no secrets in the source code. Then that code gets pulled in by the CI/CD system, and the CI/CD system has the operational secrets in it. One operational secret is the service key, that service account key, that is used to deploy code to GCP. The other operational secret is the name of a storage bucket. That Google Cloud storage bucket. And that is deployed or set as an environment variable in the runtime environment. So the runtime environment can read it. What does the runtime environment do with the name of a storage bucket? Well, when it needs a secret, like the API key for the payment API, it can go and hit that, read from that cloud storage bucket, and get that runtime secret. And what's cool about this is that now that reading of the runtime secret is managed through IAM in GCP, which means it can be really locked down who can read it. James can't read it, for example. Pari can't read it. Maybe none of the developers can read it. Maybe it's only the CTO, Sang, who can read this, and the runtime environment. So setting up this environment means operational secrets, runtime secrets separately. Let's talk about how those operational secrets are put into the CI/CD system. In GitLab, it's easy. You just enter them in the web UI. This means there's no file sitting around with these secrets. As soon as you have a file, it's very dangerous because somebody might accidentally check it in, right? In this way, somebody types them into the web UI. Nobody saves them anywhere. Once you type these in, let's see where they go next.
So if we look at the particular variables we have here, the third one down is the service account key. This is a key associated with a service account from IAM, and it's been entered here in a base64 encoded way. That way, if anyone accidentally looks at it, takes a screenshot, echoes it out to a terminal, they've not accidentally seen it. It's a nice security through obscurity. And so using that, every single job that runs in the CI/CD system can then expand on that key, taking that environment variable, decoding it, and then using that to authenticate gcloud so that it can go on to pretend to be that service account as it goes through and runs any deployment or other commands that you need to run. Now, as Pari notes here, you might find that this is a little bit easier if you were running from Cloud Build, because with Cloud Build, instead of needing to manage this key separately, you can instead grant permissions to the Cloud Build service account directly, and it will operate with that, no additional keys needed. So once you have this service account, what exactly do you do to give it those accesses? All the permissions that it needs to run builds and deployments and perform other operations. You could give it the project owner or editor role. That's the easy button way to do it. But in that case, if anything were to expose that key, the blast radius of that would be encompassing almost all the things that can be done with your GCP project.
Yeah, some could just take down the production environment with that key, right?
You just delete it, yeah.
Delete it. Ooh.
So instead, a least privilege approach is much better. Figure out exactly which roles and cloud storage bucket ACLs you need to have and assign them to the service account. That way you know that you've got the minimum exposure. What's more, since we've charted this course of every environment being its own GCP project, we might want to have a central repository for things like build artifacts and this service account, so that we can have one central source of authority and then deploy into each of those other environments. In that case, we're going to need to collect all of the different roles and permissions for the deployment process of shipping resources, shipping cloud functions into stage and production, and give that to the service account on a cross-project basis. This can be done by identifying the email address of the service account and adding it like a normal user to other projects. For runtime secrets, we've charted this course of using a cloud storage bucket as a kind of vault, which we are going to have the runtime function look up and pull in the secrets as needed. Here we have a little bit of bash magic in the first couple lines of the slide, which is looking up a cloud storage bucket that is specific to an environment, using a little trick for dynamic variable names in bash. This bucket name is then passed into the function or Cloud Run service or App Engine app when you deploy it, so that when those things start up, they can load the secret and keep it in memory to reuse for further requests in the future. Now, with all this talk of giving permissions and roles to a service account with keys exported to another system, there's a lot of access there you're still exposing, even though you're trying to get a least access approach. Being able to deploy to production is not a trivial thing. And there are a number of ways you might approach that. Since we're using GitLab, you might take the open source version of GitLab and host that on GKE. And I believe there's a Code Lab session for that on Thursday, exploring how to do that. But one approach that Pari and the Into the Woods team is exploring here is splitting up the responsibilities of what different systems will do. GitLab can be responsible for everything up through QA, and maybe Cloud Build will handle all the operations for staging and production. Since so many of our operations are wrapped up in bash scripts, they can be easily executed by any runner. And so GitLab is going to perform the same operations as Cloud Build through the lens of those scripts. And so as we've built out the additional stages, we might even add deployment and an acceptance stage for those end-to-end tests. Let's go ahead and see if that demo from the start of the talk has completed and we have a successfully deployed service. So here is the GitLab CI pipeline that we started earlier, and now we see we have some green check boxes, and the last one here with the exclamation mark looks like an accepted failure. But I'm not too worried about that right now. I want to see, did my QA environment get updated from this change? And looking into this terminal output from the CI system, it looks like it ran through all the steps, figured out an environment, and deployed to a demo environment. And here we have a URL to look at our Cloud Run service. Huh. Well, that command disappeared, didn't it? Well, since Cloud Run services deploy in an authenticated-only way, and I don't have that command handy, we will move on. Go back to the slides, please. Take it away.
All right. So now that they have the whole CI/CD pipeline set up, what have they learned along the way? Well, first, Junior James, he was a bit concerned about this CI/CD. There would be a lot of bureaucracy. He's happy that CI/CD actually helps him. Pari, who writes a lot of these scripts, she sees that monorepo, that adds complexity in the scripts, but it is worth it. Also, secrets management is always tricky. Tess notes that serverless makes CI/CD easier because you can test in environments that are exact carbon copies of your production environments. And also, those environments don't cost anything if they're not running. Finally, Sang is really happy that they can release software more predictably.